We're on 5.2, and the first definition is perpendicular bisector of a triangle. We talked about perpendicular bisector before, but now it's more related to just two triangles. Okay, so all right, so the first one is perpendicular bisector. We talked about that the other day being perpendicular, but we're representing only on triangles. All right, so you're cutting each side of the triangle in perpendicular bisector. So you'll have 3 on that triangle. Okay, 1 for each side. Okay, concurrent lines are 3 or more lines that intersect at the same point. So where those perpendicular bisectors intersect, those are called concurrent lines. And that point where they intersect is called the point of concurrency. Lots of definitions, so you know you'll have definitions on your test. And it's something called the circumcenter is that point of concurrency where the perpendicular bisectors intersect each other. That is very important. Circumcenter of a triangle is where the perpendicular bisectors intersect each other. Okay, at that single point where they intersect. Circumcenter of a triangle on 5.2. So a lot of definitions, right? Main ones you need to know. Perpendicular bisectors of a triangle, where they all intersect, is called the circumcenter of the triangle. Okay, the next one is the angle bisector of a triangle. We talked about angle bisectors. It cuts the angle in half. But more specifically, something called the incenter. The incenter of a triangle is the point of concurrency where the angles, bisectors, intersect each other. Okay, it's where the angle bisector, those lines, intersect each other. Lots of terms. So incenter, circumcenter, those are 2 important new terms. Okay, this theorem is called the concurrency of perpendicular bisectors of a triangle. Okay, so the perpendicular bisectors of a triangle intersect at a point that is from the vertices of the triangle. So PA, that length, is the same as PB, which is the same as PC. Here's what you need to know. You've got a triangle. Okay. You've got a triangle. You've got the perpendicular bisectors. Okay. That's where they intersect right here. Is called the circumcenter. Okay. Those circumcenter. Perpendicular bisector bisects the lines in 2 equal parts, right? So we know these lengths. They're going to be the same. All right, what you need to know is that from P to A, from that circumcenter to the angle, okay, from the circumcenter to the angle, and from this circumcenter to the other angle, they're all going to be the same length. Okay? They're all going to be the same length if their perpendicular bisectors intersect at the point of concurrency. Thank you. They're equal distance. They're the same distance apart. Questions so far? Yes. All right, so the next slide. We've got a boat. We got actually 3 boats. The positions of 3 boats are shown in the diagram. The boats are equal distance from the buoy. Where is the buoy? Okay, so if you draw your picture out and you make it a triangle, remember the point where they all intersect is called your circumcenter. So we're looking for the center. So you find the center of this and you draw straight down, right? And I find the center of this line, and I draw straight across. Yeah. All right, and I find the center of this line, and I draw straight across, make 90-degree angles. Well, they all intersect right here, correct? Okay, so that would be where the buoy has to be.
Really, all you got to do is put the triangle and just like two on the side of it.
Got to find the perpendicular bisector of all three sides where they intersect. That's the equal distance from all the buoys. It's all the same point.
The boat is where?
The buoy.
Buoy, where? Buoy.
Okay, the buoy is the circumcenter. It's where all your perpendicular bisectors intersect. Okay, and depending on how your picture's drawn out, they could be on the inside, it could be on the triangle, or it could be on the outside. Circumcenter changes depending on how your graph's drawn. All right, next slide. Using three perpendicular bisectors, find the center of the three locations. And we did that. This is what you need to do. Well, we did it. We drew the triangle. And so what I said how to do it is you find the midpoint of all three sides. And you said of the constructed triangle, so you have to make it a triangle. If you want to use shorthand or abbreviations, that's fine. Okay, part 2. Then we made each of them the midpoint, or made a perpendicular bisector. I'm going to kind of use different terms than perpendicular bisector. So we made a line. Each midpoint. At 90 degrees. Okay? So, in other words, I did a perpendicular bisector. I don't care which way you use it, but I made the perpendicular bisector of all three sides. And then where they intersect. And that is your circumcenter. Okay? And that is where it's equal distance from the angles, or from the points. Is that okay? So you could do that if I gave you something on the test. You could decipher which one is the circumcenter if I gave you a whole bunch of points. Vertices, B-E-R-T-I-C-E-S. All right. So the next one, we're checking this. The perpendicular bisector of this triangle, PQR, that's the big whole triangle, meet at point S. Find the distance from P to S. All right, so I'm looking for the distance or the length of PS. What would that be? 9.6. Okay, I heard 9.6. Everybody agree?
Yeah.
Yes?
Yeah.
Yes? Okay, so it is not 9.6 because 9.6 is on the outside of my triangle, and it is the same as from Q to that point that I just stopped at. So, right, it is 10 because from the circumcenter to the angle, all of those have to be the same distance. So PS is going to be 10. What is QS? It has to be 10 too because it goes from the angle to the circumcenter. So it has to be 10 also. Very good. All right. So 5.6, concurrency of angle bisectors. Right, this says the angle bisector of a triangle. So angle bisector intersect at a point that is equal distance from the sides. So the end center, which is different, the end center says that PD is equal to PS, which is equal to PE. So in other words, the angle bisector tells me that these little pieces right here, okay, that happen to meet, they should be the same. Now, whether you drew it to scale, I don't know. But if it tells you that the angle bisectors, and they end up at the same middle point, okay, those sections that make the 90-degree angle should be the same distance. Okay, now notice, it doesn't have to be, these don't have to be perpendicular bisectors. You got me? They don't mark that, so you don't know that they're perpendicular. You do know they make a 90-degree angle. Okay? You know they're perpendicular, but they don't know if they're bisecting. So beware of that. You got me? This is the end center, not the circumcenter. Okay? The end center is where the angle bisectors all intersect each other. Okay? So something that we pointed out is that these are the end centers. Okay? Not necessarily perpendicular bisectors. They sometimes end centers where the angle bisector intersect each other. The circumcenter is where the perpendicular bisectors intersect each other. So what I'm looking at here, this is the angle bisector, and it intersects this angle bisector, which intersects this angle bisector. So that is called the end center, which not always is the end center and the circumcenter the same. They can be, but don't have to be. So your question? Okay. All right. So we said that was PE and PF, so the end center, those sides, from the end center to the sides, making a 90-degree angle, are going to be the same length. All right, so here I have a huge picture with a lot of stuff going on. Take it one step at a time, otherwise you're going to be overwhelmed looking at it. I've got a triangle with a circle in the center, and that's okay. And I have angle bisectors. Angle bisectors, when they intersect, is the end center, right? So that's my end center. In my end center, I know that it's equal distance from all the sides. So all these sides are going to be the same distance, right? Okay. So just as I take it one step at a time, don't know anything about them, not yet. I just know that MH, HN, and HP are all going to be the same length because these are angle bisectors. Okay, what segments are congruent? Well, I can answer that, right? MH, HN, HP. That's all I know. Okay, there's nothing else. Didn't tell me that's perpendicular bisectors. That's all I know, is those three angles are the same. Now I need to find the length of HN and HP. Well, I know HN and HP are the same, right? We just said that. They're all congruent. But I've got to find some way of figuring it out. The only piece of information that's given to me with numbers is this length right here and this length right here. What kind of shape is that? A triangle. What kind of triangle? What do you see in that corner? It's a right triangle. And if I know two sides of a right triangle, can I find the third side? Remember how to do it? How?
You have to add two sides and then subtract two sides.
Okay, that's angles. A squared plus B squared equals C squared, and that's the Pythagorean theorem. And this only works for right triangles. A and B are your legs of your triangle, and your legs are the side that touches the 90-degree angle. So HN is a leg. Do we know HN? No, so I'm just going to call it X. All right, I don't know HN, so I'm going to say let X equal the length of HN. I don't know it. All right, what do we know the other leg? Okay, I'm only given 24 and 25. So right, it's 24. Square it. And the hypotenuse, the one across from the 90-degree angle, is 25, and you square it. So you do order of operations. Parentheses, exponents, we got those. 24 squared is 576. 25 squared is 625. It's pretty. And then you subtract the 576 from both sides, so you get x squared equals 49. And then you take the square root of both sides. Now, when you take the square root of a number, okay, when you're solving an equation, you're taking square root of both sides. You get both positive and negative. But because we're talking about length, we only want the, you're talking about distance or length, you only want the what? Do you want negative? No, right. You only want the positive because negative lengths do not exist, right? Right. So the square root of 49, only the positive is 7. So HN equals 7, right? That's what you're asked for. And then because HN and HP are the same, we know HP is 7 units, whatever it happens to be. That's very important. There's one like that on your test. Got me?
So, like, how do we get that?
I subtracted 576 from both sides. Part B. We did that. We did it all together. There are steps. 2. We have an angle bisector. Angle bisector means it cuts the angles in half. So where they create are called the end center. Okay, in that end center, the sides, that end center is equal distance from the sides with it creates a 90-degree angle. So HW or KW, XW, and WY and WZ all have to be the same length. Okay? If XW is 2D plus 7 and WZ is 4D minus 1, how do I find D? What do I know about XW and WZ? They're the same, so they're equal. If they're equal, we do what with them? Set them equal to each other. So XW we said was 2D plus 7. WZ we said it was 4D minus 1. And we put the D's on the same side, the numbers on the other, and we solve. So we subtract 2D from both sides. And I'm left with 7 equals 2D minus 1. I add 1 to both sides. And I get 8 equals 2D. How do you get D by itself? Divide. Always, because I have 2 times D, do the opposite, which is divide, and I get D equals 4. There's no unit of measure because it's just a variable.